The customer requires full wireless radio frequency coverage of the church. The red area is the preacher's pulpit. These small dots are the cylindrical pillars supporting the building. The audio equipment room is here. Here are some speakers. The light green areas are all the areas where the pastor will move. The pastor will move from the pulpit in area A to the pulpit in area B. There are large screens behind the pulpits in both area A and area B, which will cause certain interference to the wireless frequency. The customer was afraid that I would not understand and sent a live video. While such a large church, in addition to achieving comprehensive wireless radio frequency coverage in the mobile area of the on-site preacher, the customer also requires coverage in the intermediate mezzanine of these floors. After understanding the customer's needs and building structure clearly, I started to configure. First, configure the antenna for the venue. For such a large venue coverage, of course, a directional antenna should be selected. Because it involves the subsequent feeder gain compensation and full band adaptation to the receiver, I configured RL32AU with 0 to 15 dB feeder gain compensation for the customer, making the subsequent wiring more flexible for the customer. In order to ensure that the wireless video covers every point, I arranged 7 sets of antennas and required the customer to install them at the high points of the church to form a large area interactive coverage and eliminate the radio frequency in the area. After the magneto-electric radio frequency coverage is configured in place, start to distribute the radio frequency signal, because in the end, the radio frequency signals of several groups of A and B antennas need to be combined and routed to the A and B ports of the antenna distributor respectively. Therefore, we need to use the R1 to S antenna distribution hub to connect to adjacent A antennas or B antennas in series. Cold knowledge, the radio frequency will have an attenuation of about 5 dB when passing through the R1 to S antenna distributor hub. For everyone's easy understanding, we connect the A antenna signal with a green line and the B antenna signal with a red line. After using the R1 to S to collect and distribute all the A and B antennas to the R1 for D antenna distributor, ask the customer to send the on-site size diagram. Different radio frequency coaxial cables have different wire meshes. We make a conservative budget with 50 to 5 radio frequency coaxial cables, amplify the radio frequency signal attenuation at 25 to 30 meters, add an R20A active radio frequency amplifier in the middle to amplify the radio frequency signal by 15 dB. Then add an R20P coaxial cable power supply to supply power to the R20A amplifier. At the same time, it provides a power supply guarantee of DC 8 volts and 300 mA for the system. For the nearly 400-meter wiring scheme, we have made 5 sets of R20A and R20P antenna power supply and radio frequency amplification combinations on both the A and B feeders. Finally, in order to ensure the normal power supply operation of the R32AU directional antenna and R20P power supply is added in front of each directional antenna. According to the overall system radio frequency gain calculation, a gain of 5 to 8 dB can be set on each directional antenna. The actual situation will be debugged according to the on-site situation at that time. This wireless radio frequency full coverage system configuration scheme was chosen by the customer. In order to let the customer have a more intuitive understanding of the on-site wireless radio frequency signal, we gave him a U-Discover portable handheld spectrum analyzer. The customer is very happy and highly praises our service in place. If anyone has wireless coverage or wireless zoning needs, you can contact us at any time. We will design multiple schemes and product combinations according to your actual needs. In the future, we will also have more radio frequency tools to let you understand and implement more radio frequency engineering schemes.